This is section 1-6, solving compound inequalities. Our objective today is I can solve and graph compound inequalities. A compound inequality consists of two inequalities joined by the word and or the word or. To solve a compound inequality, you must solve each part of the inequality. The graph of a compound inequality containing and is the intersection of the solution sets of the two inequalities. So what that means is if we have this example right here and we have shaded in all of this area, then we have our second example, x is less than 3, we've shaded in this entire area. Then all we're going to shade in on an and statement is what they both have in common. So in this case, they have this middle area in common, so that's what we would shade in on this compound inequality. For solving and compound inequalities, there's two methods we can use. One method is to solve them separately. Another method is to solve both together. You can use whichever one you feel more comfortable with, but I'm going to show you both for this one. So it says to solve 8 is less than 3y minus 7 less than or equal to 23. In the first example, you can see that I wrote these out separately, two separate equations based off of what they gave me. And now I can solve each of these. So here I would add 7 to both sides. So I'd end up with 15 is less than 3y. I would divide both sides by 3. So I'd end up with 5 is less than y. In this case, I'm going to add 7 to both sides. So I'm going to have 3y is less than or equal to 30. I'm going to divide by 3. So y is less than or equal to 10. And we're going to put an and in between because this is an and statement. In method 2, I'm going to leave the full equation exactly how they gave it to me. So 8 is less than 3y minus 7 less than or equal to 23. Now, in this case, we still want to get this y by itself, so we're still going to add the 7. We're still going to divide by the 3, but whatever we do to the middle section, we must do to the right side, and we must also do it to the left side. So here I'm going to go ahead and add 7. If I add 7 to the middle, I must add it to the right and add it to the left. So I'm going to end up with 15 is less than 3y is less than or equal to 30. And if I divide by 3, I'm going to end up with 5 is less than y is less than or equal to 10. And if we look at these two answers, here we have 5 is less than y, here we have 5 is less than y. Here we have y is less than or equal to 10, here we have y is less than or equal to 10. So you're going to get the same answer either way you do it. You just need to pick whichever one's more comfortable for you. So let's go ahead and graph this. I'm going to go ahead and put whichever numbers they give me, which in this case is 5 and 10, on my number line. And now I need to decide, okay, is it an open or a closed circle? Well, when we're looking at the 5, we just have a less than sign, so we know it's going to be just an open circle. And we know that from the 5, we know that 5 is going to be less than y. So I'm going to go ahead and just rewrite this. It's going to make it easier for us to see. If we rewrote this, we'd have y is greater than 5, which means from the 5, I'm going to be shading to the right. Okay, let's go ahead and look at the 10. Since it's y is less than or equal to 10, we want to shade the area n on the 10. And then we know that we would need to shade to the left of the 10. So if we look, this is the area that we have in common. So that's the area that we're going to shade on the line. We're going to shade everything that's in between those two values. The graph of a compound inequality containing or is the union of the solution sets of the two inequalities. That means when we're going to graph this, we're just going to shade in anything that either one of them would be. So we're no longer looking for what they have in common. We're just shading in anything that either one of them would cover. So let's go ahead and take a look at this example. We have k plus 6 is less than negative 4, or 3k is greater than or equal to 14. So we're going to solve these exactly like we did when we just solved regular inequalities. I'm going to go ahead and subtract 6 from both sides here. So I have k is less than negative 10, or over here we would divide both sides by 3. So we're going to end up with k is greater than or equal to 14 over 3. Okay, so this is the answer that we end up with. Now, we do want to look at how we're going to graph this. Since 14 over 3 is going to be a little hard for us to graph, I'm going to go ahead and write what that's going to be as a decimal off to the side. So we're going to have 4.6 repeating. I'm still going to leave my answer is k is less than negative 10 or k is greater than or equal to 14 over 3. But just for graphing purposes, I'm going to go ahead and leave it, or I'm going to be able to figure out that 14 over 3 is 4.6 repeating. So if I go ahead and graph this, I know that negative 10 is going to be down on the bottom because it's negative. And then we're going to have 14 over 3 up here. We could also write it as 4.6 repeating if we wanted to. We know we're going to have an open circle on 10, and that we're going to shade to the left. Now, since we're not looking for what they have in common, I'm just going to go ahead and shade directly on my line because it doesn't matter what they have in common anymore. So on this one, k is greater than or equal to 14 over 3. We know it's going to be a closed circle, and we also know we're going to shade to the right. Absolute value inequalities are going to work slightly different. So it's a little bit easier with these if we go ahead and graph and then create our inequality. So if I go ahead and graph this, I know I want to include 3. And here it says that x is less than 3. Absolute value of x is less than 3. Now we know when we're talking about absolute value, we also want to talk about the negative. So we know if we took the absolute value of 3, we would get 3. We know if we took the absolute value of negative 3, we'd get 3. Now in this case, it says less than 3. So we want to put an open circle, and we know we would shade this way from our 3 because it's less than. Now, an interesting characteristic about the absolute values is that they're either going to be shaded in the middle or on the outsides. So here, we're also going to keep an open circle on the negative 3, and we're going to shade over here to the right. We know that the value has to be somewhere in the middle. So we're going to shade, and then we're going to go ahead and say that x is less than 3 and x is greater than or equal to negative 3. And that's going to be our answer we solved, and it's going to be our graph. Let's take a look at the second one. So let's go ahead and do the graph again. So here we know we want to have 5, and we know we want to have negative 5. So with absolute value, you're always going to have what they give you and the negative of that value. So we know it's going to be open circle on both of these because of the sign that they gave us. And then it says that x is greater, x will be greater. So we'll know we're shade to the right hand side of the 5. And since we shaded to the right, and we know that absolute value has to be to the sides or to the middle, we know that we'll shade to the left of the negative 5. So then if we want to write down our answer, we're going to say that x is greater than 5 or x is less than negative 5. And that'll be our final answer with our graph. Okay, so our last example is to solve a multi-step absolute value inequality. And I went ahead and copied a little piece of your notes over here to the right, and that's going to help us be able to set this dude up. So we have the absolute value of 6y minus 5 is greater than or equal to 13. So we want to take a look at this first one over here because this is talking about greater than. So we're going to set this up 2 different ways. We're going to have our equation, which is 6y minus 5 is greater than or equal to 13. And we're also going to have 6y minus 5 is less than negative, less than or equal to negative 13. So all I did was follow the formula that they gave us over here. And now I can solve each of these. So I'm going to add 5 to both sides. So I have 6y is greater than or equal to 18. I can divide by 6. So I'm going to have y is greater than or equal to 3. Over here, I'm going to add 5 to both sides. So I have 6y is less than or equal to negative 8. And then I can divide both sides by 6. So I'm going to get y is less than or equal to negative 4/3. So now we want to go ahead and graph both of these. So we'll go ahead and draw our number line. Now we know that negative 4/3 is going to be down here just because it's a negative number. 3 will be up top. Both will have closed circles. And we also know that this is going to be an OR statement. So we know that y is greater than or equal to 3. So we'll shade up here. And y is less than or equal to negative 4/3. So we'll shade down here.